All right, so welcome Laura Lee to the stage.
In the current age of human space exploration, we are bringing people back to the moon through NASA's Artemis campaign. And in NASA's Artemis campaign, we're not only bringing people back to the moon, but we're going to begin to understand the challenges and uncertainties that come with longer duration human presence on other planetary bodies. And what we learned from the Artemis campaign, we will eventually bring descending crewed missions to Mars. And these challenges at Mars will be even harder to tackle from here on Earth. So one of the challenges I'm looking into is how we can sustain these humans in the form of food production. The current method that's being used is sending resupply missions of prepackaged foods to the International Space Station, which works perfectly fine for these short distances. But as we increase the distance of these missions, the risk increases greatly. So having a more reliable and more sustainable food options for these astronauts will really increase and improve the success of these future missions. In past plant growth studies in soils similar to the Moon and Mars, these plants have shown signs of stress due to nutrient limitation, metal toxicity, as well as other stressors that come with growing in these soils. So the possible solution I'm looking into is incorporating something called arbuscular mycorrhizal fungi. This is a type of root fungus, here shown in pink, that is associated with most plants here on Earth and has been around ever since the very first land plant. And the role of this fungi is that they're able to break down inaccessible nutrients, shown in green. They can expand the search for water, shown in blue. And they're also able to reduce plant stress. In my past 2 plant growth studies, I've been growing corn in soils with similar mineralogy to the Moon and Mars, with and without this root fungus, in our local campus greenhouse. And we're showing some promising results. In the corn crops that grow with the fungi, we see an improvement in biomass production. So these plants grow larger with more weight. We also see improvement in yield, increased yield production, so more ears of corn. We see an increase in their overall survival probability in these soils. And we see improvements in overall plant health through leaf chlorophyll content, and in some cases, higher nitrogen production. So overall, our studies are showing some promising results that this type of root fungus can build a more sustainable and more reliable food production system on the Moon and Mars for future missions. Thank you.